exponential growth.
Scream, are you smarter than Australia?
I have no idea.
Spelling bee.
Oh, epically fail.
Yeah.
All right. Exponential functions have the form a times b to the x, where a is not 0. B is our base, because remember it's what our exponent is based on. Our x is now in the exponent. And a is typically a positive number other than 1. We're just going to work on the growth tomorrow. We'll deal with decay functions. So b has to be greater than 1, meaning it's not a fraction or a decimal. Well, it could be a fraction or a decimal, but it has to be one larger than 1. So it could be like 1.5, 3 halves. It is an exponential growth function. So this is the general parent graph for our exponential function. An asymptote is a line that our graph gets really, really, really close to, but it never touches. Because our graph here, even though it looks like it's touching the x-axis, it's not. It's getting really, 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 really close to it, but it's never quite touching it. So it's like 1 over 100, 1 over 1,000. Those numbers are really, really close to 0, but they're not technically 0, right? So an asymptote means we're never going to cross that. An exponential growth function rises from the left to the right because it's growing. So steps for graphing. We're making an X and Y t-chart, counter points, and draw a smooth curve. Today we're focusing on the growth, so we're going to be making it from left to right. Bless you. So we're going to start with use the same basic points when we are graphing today. So we're going to do our little t-chart here. And we're going to start with x equals -2. So all we have to do is plug in -2 where there's an x. So we have 2 to the -2. Well, what does it mean to have a negative exponent? How do we make it not negative? Bring it to the basement so that becomes 1 over 2 squared. Well, what is 2 squared? 4. So we have 1/4 is our first one. Then we're going to go to -1 for our x. So we have 2 to the -1, which is the same as 1 over 2. Technically, it's 2 to the first, but do I need the 1 there? No. Then moving on, plugging in 0. 2 to the 0. Anything to the 0 power is 1. We're going to plug in a total of 5 points. Then if we plug in 1, we get 2 to the first, which is 2. Plug in 2, we get 2 squared, which is 4. So our growth factor, or our base here, is what? 2. So that means every time we plug in a value, what are we doing to it? Every time we move up, look at our numbers. So we go 1/4, 1/2, 1, 2, 4. We're doubling it. Our growth factor is 2, so we're doubling it. Like bacteria doubles after every so many hours. It grows exponentially. So it is constantly doubling. And notice our initial point is actually the value that's in front of our base, or a value. Because if there was a number in front of that 2, what would it be? If there was a number in front of that 2. So if I had that is written as y equals a times b to the x. So we have 2 to the x. What value is really here for that a?
0.
Well, if it was 0, it'd be gone. So it'd be 1. That's technically my initial point. That's my starting point. That's where when x is 0, y is at 1. Then we have -1, 1/2, -2, 1/4, and we're just going to get closer and closer to that asymptote. So then at 1, we're at 2.
Is 0 always the asymptote, the horizontal?
Yes and no. For the parent function, yes. Unless we either add or subtract something on the outside, it will do it. If we add or subtract, if we subtract, we're actually shifting our entire graph down. If we're adding it, we're actually shifting the whole thing up. So then at 2, we're at 4. 1, 2, 3, 4. And at 3, if we follow this trend and double it every time, what would we be for 3? 8, which is off our chart for this one. Off the chart. You can start out, we're going to start out with -2 as our regular one. But what's different with this one? If it's in our y equals a times b to the x. What's our a this time? 1/2. So technically, our initial point, or that point where the x is 0, will be 1/2. If you don't see that right away, we can jump to our t-chart. Start at -2, so 1/2 times 4 to the -2. We have it to the negative, that's really 1/4 squared. Well, 4 squared is, so 1/2 times 1/16. How do you multiply fractions? Straight across, so that'd be 1/32. Then we move on to -1. 1/2 times 4 to the -1. What does the negative exponent do? Goes to the basement, makes it a fraction, so we get 1/2 times 1/4. So we get 1/8. What are we doing every time with our growth factor?
Getting smaller.
Quadrupling. It's what's with our exponent is our base function or our growth factor. So this time we're quadrupling it every time. We're multiplying it by 4. So like we said, if we plugged in 0, 1/2 times 4 to the 0, anything to the 0 is 1. So we just get 1/2. If we are quadrupling it, technically 1/2 times 4 is going to give us 2, but we can go ahead and see if we take 1/2 times 4 to the first, 1/2 times 4 is indeed 2. And if we were quadrupling it again, we could just take that 2 and multiply it by 4, and we know we get 8. Or we can go this way, 1/2 times 4 to the second. It's 1/2 of 16, which is 8. So we said that initial point was going to be 0, 1/2, which we saw when we plugged it in, and it was. You can kind of just go really, really low down estimating that 1/32 and 1/8. At 1, we're at 2. At 2, we're already up at 8. Think you guys can handle doing the next one on your own? All right. Sometimes the second is not even the hard part. What do you think is the hardest part? When you write the properties?
Ln. 3 to the -x minus 1.
Write that down.
No. Okay. We have
Equals?
we have to solve for n. Fine. Oh, like figuring out the go out of that? Don't want to just be one here, one here, I don't get that part.
What is the test?
And how you learn that you do it. Remember a 0? We can't do that.
We might start evaluating logarithms and tomorrow to help you guys.
Oh, thank you so much. That's otherwise I'm just gonna
Oh,
call it again.
Thanks. Because you have to think of them as inverses. We're working with Adam on that. Lots of times spent on FaceTime. How many are in here are in college?
1, 2, 3,
4? Okay.
Oh,
There we go. Hey, Caleb, when you guys banquet?
Saturday.
Sweet, I'll be there.
Why?
Sweet. Just
They're eating.
Damn.
He's gonna show up in class.
There's no food at the banquet?
Because, okay, let's see, because it's our awards at 10. But then volleyball teams going to the same class state volleyball for eating candy.
Drive in August.
Excuse me.
All right. Let's go through this one. So we have our t-chart. We start with -2, so 1/4 times 5 to the -2. Negative exponent does what? Brings it to the bottom. So that's the same as 1/4 times 1/5 squared. What is 5 squared?
25.
So 1/4 times 1/25. 1/100. What are we multiplying by every time? 5. We're taking every one of these and multiplying by 5. So technically 5/100 is the same as 1/20. And we can see that if we plug that in -1. 5 to the -1, which flips it. 1/4 times 1/5
120.
is 1/20. Plug in 0. 1/4 times 5 to the 0. Anything to the 0 power is 1. So we just end up with 1/4. Plug in 1. 1/4 times 5 to the first is just 5. That'd be 5/4. In this case, I typically tell you guys to leave them as improper fractions, but because we're graphing, you can go ahead and write that as a mixed number. 1 1/4. And if we plug it in by 2, well, we're multiplying it by 5. That'd be 25/4. If we see it here, we get 5 squared, which is the same as 25. So 25/4 is the same as 6 1/4. So really the first one I can kind of graph is 0 1/4, 1 1/4, 2 6/4.
How do you even graph 1/100? It's like nothing.
Yeah, well that's why we just kind of have that asymptote there. Why don't you go and try that the next one? Yeah, I got to do one. Oh yeah. That one would have been due for no, Thursday.
It's Monday, hon.
I'm so confused.
Oh, I think it's because I had a question. And I just forgot to ask you. I love how you ask me like I know why do I know this?
I can't get in my interview really late.
Oh,
Number 4.
Friday?
oh, big time.
I had to do on Sunday.
Oh,
I did turn in today.
They're putting up.
Everyone is studying hall. Actually, right now, I can just turn it in.
I'm told right now I can't.
Ben told me to, Doug told me to, you told me to.
We were in there today and the staff was in there and she had me do homework for revisions. Yeah. Those are what Ben told me to do. How long is it?
Yeah.
It can be as long as you want.
You never specified the age.
Yeah.
They said it should be 3 to 5.
He's following
but
exactly
it
the
could be
book
as
says,
many
but
as
the
you
book
want.
never specifies age count.
Yeah, I did. I asked him, he said.
He doesn't
Yeah,
judge
it
based
should
on
be
how
3 to
long.
5, but maybe the ones he said, he said, we make an argument that says.
Like a page of recording. I know that we said 1 page.
One page per week.
That's like a lot of stuff.
Yep.
Is it like a page and a half?
Maybe I have a banana suit. I call it a banana suit. Here, let's get rid of it.
I work out.
I want it. The best part was one time we were visiting them up the road, wrapping lunch, and he's like, can you bring me a banana for lunch? I found the bananas to go. So I sat in the parking lot and had bananas.
So you do that. Take out the bus and just put it in the parking lot. And so they found it on like the light pole thing on the bottom. And someone like was gonna put it in their car. I'm gonna do that. Yeah.
Or what they-
So I'm like,
Alright, so we got our x and y. So we start with -2, 1/2 times 3 to the -2. What does the negative exponent do? Brings it to the basement. So 1/2 times 1/3 squared. What is 3 squared? So we have 1/9 times 1/2 is 1/18. Plug in -1. 1/2 times 3 to the -1. Again, that brings it to the basement. So 1/2 times 1/3 gives me 1/6. Plug in 0. 1/2 times 3 to the 0. Anything to the 0 is? 1. So that one would just be
1.5.
1/2. Plug in a 1.
Yeah.
1/2 times
This one's 1.5.
3 to the first is 3/2 or 1.5. Every time, what are we doing? Times in by 3. So 1/2 times 3 squared. 1/2 times 9 gives us 9/2 or 4.5. So really the first one I can kind of graph is 0, 1.5. Then we're at 1, 1.5, and 2 at 4.5.
Oh, this is Kramer. We almost lost.
I saw that.
Scary.
I like threw that and I caught it. I'm like, oh no, it's over. They're gonna get this 2-point version and it's gonna be over. I was a little scared.
Do you know who their quarterback is? It's like Jake something.
Snyder?
Nope, starts with an H, I think. I don't know. But his career is over though, so.
Was he senior?
Yeah.
I sound like he got like. I was like, why'd you like break him?
Mr. Elliott put up all the names of what, that their careers are over for seniors.